Hello everyone, you are welcome to this lesson. In this video, we are going to solve this question I have here on the screen. The question says two forces are applied at point B of beam AB. Determine the magnitude and direction of their resultant using trigonometry. So let's look at how you are going to solve this question. So we have the figure here. We have a 2 kilonewton acting at point B, and then it makes an angle of 40 degrees with the y-axis. And then we have a 3 kilonewton force acting at point B, which is also making an angle of 60 degrees with the y-axis. So let's look at how you are going to solve this question. Okay, so I'm going to start by drawing the free body diagram. Okay, so let's look at that. Let's take this to be our point B. Okay, and then I'm going to draw the force vector for the 2 kilonewton force here. Okay, let this represent the 2 kilonewton force, and then let this represent the 3 kilonewton force. Okay, all right, so let's look at what I'm going to do next. Okay, so now let me draw the axis. Okay, let's take this to be, let me change the color. Let's take this to be the y-axis. Okay, and then let's take this to be the x-axis. So this is the x-axis and then this is the y-axis. Okay guys, so what I'll do next is that I will draw a force, okay, another force vector to be parallel to the 2 kilonewton. Okay, let me just name them now. This is the 2 kilonewton. Okay, and then this is the 3 kilonewton. Okay, so I have drawn one force vector to be parallel to the 2 kilonewton. Okay, and then I'll draw another to be parallel to the 3 kilonewton. Okay, this is what we have. Okay, so let's do the naming again. This is our 2 kilonewton. Okay, that's also 2 kilonewton, and then this is 3 kilonewton. Okay, so now what I'll do is that I will join where their tails meet to where the heads meet. Okay, and then the magnitude of this vector here becomes the resultant force, and then that's the value that we want to find. Okay, so now what you're going to do is that since we know two sides, which is the 2 kilonewton and the 3 kilonewton, we can easily find the resultant force by knowing the angle opposite to the resultant force, which is this angle here, which I'll name as angle A. Okay, so if you know this angle here, we can find the resultant force easily. So let's look at how you are going to find that angle. Okay, so to find the angle, what I'll do is that I will draw an axis here, okay, to represent the x-axis, and then I'll draw another here, okay, to represent the y-axis. Okay, let's take note of that. Okay, so let's see what will happen. Okay, so you see that this angle here is the 40 degrees, right? This is the 40 degrees. So we're going to have another 40 degrees here because they are alternating, okay, z angles. Okay, that's what is going to happen. Okay, so what I'll do is that I'll come and do the same thing here. Okay, I will draw a y-axis here. Let me clean this. 2 kilonewton. Okay, and then I will draw an axis here. Okay, let this represent the y-axis. Okay, and then we know this is our 2 kilonewton. Okay, so let's just keep that in mind. Okay, so if I do that, then that means that this angle here is also going to be 40 degrees, right? Okay, this angle is also going to be 40 degrees, and then this small angle here also will be what, 40 degrees. Okay, but I'll clean that for now. Okay, so we have our 40 degrees there, and then you see that the 3 kilonewton, okay, makes an angle of 60 degrees with what, the y-axis. Okay, so this angle here will become 60 degrees. Okay, so you see that now we can easily find the value of what, angle A, right? Because the sum of all these three angles here should give us what, a value of what, 180. So you are going to have 40 degrees plus angle A plus 60 degrees, okay, to be equal to 180 degrees. So you're going to have A to be equal to 180 minus 40 plus 60, okay. So this will give us A to be equal to 180 degrees, okay, minus, let me just bring the degrees, okay, 180 degrees minus what? 100 degrees. So that gives us A to be equal to what? 80 degrees. So now we know the angle opposite the resultant force. So we can use the cosine rule to find the value of what? The resultant force. So from the cosine rule, the resultant force R, okay, that will be R squared will be equal to the square of the 3 kilonewton plus the square of the 2 kilonewton minus 2 multiplying 3 times 2 multiplying cosine of the angle opposite the resultant force, that's cosine of what? 80 degrees. So we're going to simplify this to get the value of the resultant force. So let's look at that. So 3 squared will give us a value of 9, and then 2 squared will give us 4. So 9 plus 4, okay, 9 plus 4, okay, minus 6, okay. We have 6 multiplying 2, that gives us 12. So minus 12 cosine of 80, okay. So let's simplify this and see what you are going to get. Let me clean this and then move this up. Okay, so let's see. So you are going to have r squared to be equal to 9 plus 4, which will give us 13. Okay, you're going to have 13, and then let's find the value of 12 cosine of 80. That'll give us minus 2, okay, minus 2.08. Okay, so let's simplify this and see what you're going to get. So 13 minus 2.08 will give us a value of 10.92. Okay, so the resultant force will be equal to the square root of what? This value. So let's see what you're going to get. So that will give us the resultant force to be equal to 3.3 kilonewton. Okay, so that's the value for the resultant force. So now that you know the value of the resultant force, you have to find the angle it makes with the x-axis. Okay, in this case, you're going to find the angle it makes with the positive x-axis. So let's look at how you are going to do that. Okay, so measuring the angle the resultant force makes with the positive x-axis, okay, will be this angle here. Okay, that will be this angle here. Let's name this as theta. Okay, so how are we going to find this angle? You can see that you can find this angle easily if you know the value for this angle here, right? Because if you subtract this value here from 90 degrees, then you're going to get this theta. So our main goal here will be to find a small angle. Let's name it as angle B. Okay, let's name it as what? Angle B. Okay, so now we know this angle here to be 40 degrees. Okay, so you know that the 40 degrees plus the angle B is also going to give us what? The value of what? Another angle. Okay, so let's name that angle. Let's name that angle C. Okay, so we are naming that angle as what? C. Okay, so in that case, this whole angle here becomes what? Angle C. Okay, let's take note of that. So that means the 40 degrees plus angle B should give us what? Angle C, right? So you notice that as soon as we find the value of angle C, finding B will be what? Very easy for us. But how do you find the value of what? Angle C? You're going to find the value of angle C using the sine rule. Okay, so let's look at it. Let's look at that. You see that angle C here, okay, will be opposite to the 3 kilonewton. Okay, that's the angle opposite to what? This 3 kilonewton here. Okay, so you're going to have the sine of C divided by the 3 kilonewton. Okay, and then this should be equal to, let's use the angle opposite to the resultant force, which is this angle A, and then we know that to be what? 80 degrees. So you're going to have equal the sine of what? 80 degrees, okay, divided by the resultant force, which is now 3.3 kilonewton. Okay, that's the value we found. So you have to find the value of what? C. Okay, so you're going to have sine C to be equal to the sine of 80 degrees divided by 3.3 multiplying with 3. Okay, so let's see what you are going to get for this. So let me continue from here. I'm going to have sine C to be equal to, let's find the value of sine 80 divided by 3.3 times 3. Okay, that gives us a value of what? 0. What? 9. Okay, so C will be equal to the sine inverse of 0.9. Let's see what you are going to get. So the sine inverse of 0.9 will give us a value of what? 64.16 degrees. So that's the value of what? Angle C. So now that you know the value of angle C, we can easily find angle what? B. Okay, so let's go ahead and find angle B. So we're going to have 40 degrees plus angle B should be equal to what? C, which is now 64.16 degrees. Okay, so we're going to have angle B to be equal to 64.16 degrees minus the 40 degrees. Okay, so let's see what you're going to get for the B. So we have 64.16 minus 40. That gives us a value of 24.16 degrees. That's the value of what? Angle B. So we can subtract this value, okay, from 90 degrees to get the value of what? Theta. Okay, so let's look at that. So theta will be equal to 90 degrees minus what? 24.16 degrees. Okay, so let's see what you're going to get. So 90 minus 24.16. Okay, that'll give us a value of what? 65.84 degrees. So that'll be the value that the resultant force will be making with what? The positive x-axis. So now we found the resultant force. Okay, then we know that it makes an angle theta with the positive x-axis, which is equal to 65.84 degrees. Thank you very much for watching this video. Please, if you are new to this channel, kindly like the video and also subscribe to the channel. Thank you.